Welcome back to class. Today we are going to still be in Unit 1, which is one variable statistics, but we're going to move on to Lesson 4. This one is titled The Shape of Distribution. If you're in class, you can work in your small groups. We'll go through, make sure nobody has any questions. If you want to do it on your own, you're more than welcome to just put on a pair of headphones, listen to this video, try to work through the activities on your own. Again, make sure you get my attention if you have any questions, and I will take the time to clarify those for you. If you are absent today, thank you for taking the time to get online and watch this video. Remember, there is the Google Meet link that I keep posted on my whiteboard in the classroom. You can log on, let me know that you're working, and ask me any questions if you have any. Okay, that way when you come back to class, you can pick right up where the rest of us are, and you don't fall behind. So if we get into the PowerPoint today, this one says we're going to explore data and describe the distributions. What this means is our distributions are going to have different shapes. And the shapes of the distributions are going to allow us to convey information to the people that we are trying to get that information to. Or if they're the ones putting out the information, it's going to allow us to get a better idea of what that information is. So we're going to look today at how we use different terms to describe the shape and then what that tells us about those distributions. You see we have two learning targets today. The first one says, I can describe the shape of a distribution using these terms. Okay, these are the 5 terms that you need to ensure you understand what they mean, what they look like, and what that means for our calculations. Okay. So we have symmetric, we have skewed, uniform, bimodal, and bell-shaped. Those are the 5 terms we are going to be using to describe, and sometimes a distribution could actually be more than one of these. Our second learning target is for you to be able to say that you can use a graphical representation, meaning a dot plot, a histogram, or a box plot, in order to suggest a situation that produced the data. So one of your activities is going to ask you to look at these dot plots and histograms and try to come up with a question that might have been asked that would give those kind of results. So by the end of this lesson, you want to be able to say that you feel comfortable making those 2 statements. If you are not comfortable making either or both of those statements at the end of class, then use time to ask me questions to help clarify these for you. So we're going to start up with our warm-up. This one should take about 10 minutes. Again, feel free to work by yourself or in a group. It is available on Kitum. So if you would like to go on Kitum and do it there, if you prefer to use one of the workbooks, you can go grab a workbook off the shelf and write it in there. If you just want to do it on a piece of paper, you can go to one of the whiteboards around the room. Whatever you're more comfortable doing, go ahead. But as we look at it, they're going to give you 4 different dot plots. And they ask which one doesn't belong. Now, the key to this warm-up activity is that you could make an argument for every single one of these being the one that doesn't belong. So whether it's just you alone looking through or whether you're talking to those around you, try to see if you can come up with a reason as to why each one of these is uniquely different. So spend about 7 minutes of it working, and then we'll come back together as a whole class for about the last 3 minutes, and we'll talk through these distributions and we'll see what we came up with. Okay, so as you were working in your small groups or by yourself, I hope these 5 words came back to you. All right, I talked about these being the 5 terms we would use when I was going over the learning targets. These are the 5 words we are looking to use when we're describing each of these shapes in the warm-up. So symmetric means that if I go out to the left and the right from the middle, then it's going to change or stay the same in both directions. If we say skewed, that means I have a distribution shape where most of the data is on one end or the other, and there's a tail on the opposite end from where that majority data is. Uniform means my data looks almost the same going all the way across. So kind of like a table or a shelf. It's kind of flat going across. The term bimodal, if you think about a bicycle or bi-weekly, bi means 2. Mode is a statistics term that means the majority of our answers or the peak of our distribution. So if we say bimodal, we're saying there are 2 peaks. And then the last term here is bell-shaped. All right, we know what a bell looks like. When we say bell-shaped, that means we can start in the center, and then our shape goes left and right at about the same rate and kind of curves down and makes a bell shape. Okay, so hopefully when describing the 4, that's what you were looking for, is being able to describe each of them using those terms. Next, we have activity 4.2, which is called matching distributions. This should take about 15 minutes. In this activity, I am going to give you a set of cards. And in that set of cards, you're going to have dot plots and you're going to have histograms. And working in your small groups, what you're trying to do is figure out which dot plot matches which histogram. There is a 1-to-1 matching. Then every time you think you have found a matching set, I need you to talk with those around you and explain to them how you figured that out. All right, we could be looking at the labeling. We could be looking at the shape of the distributions. So you are trying to pay attention to where the dots are, where the bars are, what the labels are, how many dots there are, and the shapes, and try to figure out which dot plot matches to which histogram. If you think you find a pair, talk about it with your partners around you and come to a consensus. And we'll take about 10 minutes of you working with those around you. I'll move around the room. If you have any questions, you can get my attention. I'll come over, make sure you're on the right path. And then about the last 5 minutes of the activity time, I'll bring us back together and we will go ahead and make sure everybody finds the correct matches and is able to explain why each of those matches is correct. Okay, so hopefully as you were working in your groups, you kind of looked at each of these pairings and you thought, what do I notice and what do I wonder? So if we look at this example here, I might notice something like my numbering system starting at 79, my numbering system down here starting at 79, then my numbering system ending at 95, and also ending at 95 down here. So we could be looking at that as a way to start saying these could match, these definitely don't. And then aside from that, maybe we're looking at our shape. So if we notice, this distribution has the majority of our data on the left with our tail going to the right. When I look at these dot plots, I again see the majority of my data here with a long tail that goes to the right. Anytime we see the majority of data on one end or the other, we call this skewed. And because we want as much information as possible when we name it, you name it skewed and you give the direction of the tail. So in this case, the tail is to the right. So I would say this is skewed right. I would notice that my beginning and endings are the same, and I would notice they both appear to have that same shape, and I could say that these two match. All right, so going through it, we looked through, you tried to find matches, you explained with your partner why you believed it was a match, until your group was able to come up with a consensus on which ones were matches. Hopefully, you listened to anyone in your group who believed they had found the correct ones. Remember, we want this to be a class where we work together and help each other grow. So make sure that when someone else in your group is talking and giving you the reason why they came to an answer, make sure you give them your attention. Make sure that you listen. And then if you disagree, don't yell at each other, but calmly explain which part of their explanation you disagree with and give your reasoning as to why you think a different one might be a match. And once you found all of your matches, hopefully you were able to use those 5 terms in order to describe them. And remember, you can have more than one term describe each distribution. And those terms again are bell shape, bimodal, uniform, symmetric, and skewed. Those are the 5 key terms. So now that we're done, which matches did you think were tricky? Which ones did you have trouble with? And why did you have trouble with them? What made them more difficult than other ones that you thought were pretty easy to match? Okay, now what vocabulary was useful to describe the shape of the distributions? Okay, hopefully you were trying to use the 5 terms that we've talked about. Bell shape, if you have most of the data in the middle, and then it goes out to the left and right and curves down in a bell shape. Bimodal, if you have 2 peaks. Uniform, if it looks fairly flat and unchanging. Skewed, if most of the data is to one side with a tail that goes to the other side. And then finally, symmetrical. Symmetrical might be uniform because it goes from the middle and changes at the same rate, which is not at all in the left and right direction. It could be bell-shaped. You could even have bimodal that is symmetrical, because if I have the center is low and then it peaks up at both ends, I could take that, fold it in half, and they would roughly match. That would be symmetrical. And it asks, were there any matches that could be described by more than one of these terms? Okay. A lot of time what you're going to see is that you can name something as bimodal or uniform or bell-shaped, and then you can also label it as being symmetrical. Because when we think about symmetrical, we're thinking if I took that shape and I folded it in half, would the 2 sides match? Now with skewed, that's not going to be possible because I'm going to have most of my data on one side, I'm going to have a tail on the other, and when I try to fold them in half, they don't match. But if I have a uniform shape, I can fold it in half and they match. If I have two peaks, fold it in half, they could match. And if I have a bell shape, then when I fold it in half, they could also match. So we could have more than one of these terms describing any one shape. Okay, our next activity should take about 10 minutes. This is 4.3, where did the distribution come from? So this activity is going back to one of our learning targets. Remember, we said not only did we want to be able to use the vocabulary in order to name the shapes and describe them, but we also wanted to be able to take the shape and the labeling and understand what type of question might we ask that would give us that distribution with those numbers if it were asked. So we're going to take about 10 minutes to work on this activity. Again, you can do this on the Kidum website. You can go to the whiteboards. You can do it in a workbook at your desk, whichever way you're most comfortable with, as long as you are participating in the activity. So it says your teacher will assign you some of the matched distributions. I'm going to let you go through and just pick any of them that you feel comfortable coming up with a question that might have been asked in order to produce whichever matching pair you're looking at. Okay, so whether you want to work together as a group on one at a time, or whether you want to divide them up in your group so that your group can get more of them done within the time limit. That is completely up to you, whatever you're comfortable with. Some things that you can think about. How do you use the shape of the data to come up with your question? So think about what it means. If I have a bell shape, then that is saying that the majority of people are going to give me the answer that's in the middle, and then I'm going to have a few people that give me the answers on the extremes. If I have a uniform distribution, then I'm going to have some type of question where I expect my answers to be distributed evenly. I expect the same number of people to give me an answer on the low end as I do to give me an answer in the middle, as well as an answer on the high end. That would give me uniform. If I had a skewed distribution shape, then it's a question where I would expect most people to answer either on the low end or the high end, with only a few people answering opposite of that. So think about, what does it mean if I'm looking at the shape? What kind of question would I expect people to answer a certain way on? Question number 2, would you always expect your question to result in one of these specific distributions? So if you asked a question, but you asked that same question to people here in your class versus as the school, as a whole school, or if you went to another state or another country and asked the same question, do you think that you would end up with the same shape of distribution as what we have here in this example? Okay. So these next slides give you the textbook's answer as to what the actual questions were that were asked. So one of them was, how many points did Kieran score in each of his 22 games this season? Which pair do we think matches that? Next, what were typical low temperatures in a Siberian town during January? Which matching pair do we think represents that question? Third question, on a scale of 1 to 8, how was the service at the restaurant? Which matching pair do you think answers that question? Question 4, how many questions did people get correct on the vocabulary test the first week of school? Which matching pair do you think represents this question? Question 5. How many questions did people get correct on the vocabulary test the second week of school? Which matching pair do you think represents this question? Question 6. How many feet below the surface were each of the core samples taken? Which matching pair do you think represents this question? Question 7. How many trees are in my backyard at various temperatures? Which matching pair do you think answers this question? Question 8. What was the sum when you spun a spinner labeled 0 to 5 twice? Which matching pair do you think could represent this question? Question number 9. What was the weight of the crystal you grew in chemistry class? Which matching pair do you think represents question 9? And finally, question number 10. How many questions did students get correct on a 10-item matching test? Which matching pair do you think represents this question? Okay, so now that we've come to the end of this activity, what have you learned about the distribution now that you think that you can think of the data in a real situation? So, is there anything that stands out to you about what we've talked about that would allow you to take the data that is given to you in a visual form, such as a dot plot or a histogram, and would allow you to understand what that data represents in a real world situation? Okay. And now we're going to end with our cool down. Remember, our cooldowns must always be completed on the Kidam website. So if you have not gone to the website yet, please do so now. We're going to do cooldown 4.4, which is titled Distribution Types. We're going to have about 5 minutes. And remember, cooldowns are for you individually. It is to allow me and the district to understand how comfortable you are with the material in this lesson so that we can plan moving forward as you get closer and closer to the end of unit exam as well as the midterm, which will have some of this information on it as well. So this is what it will look like within Kidam. You can see that you're going to type your answers in. So you have questions. what does a symmetric data set look like? What does it mean to say that the shape of a distribution is uniform? Have you heard of a bell curve before? How does this relate to a bell-shaped distribution? What is an example of a context where you would expect to find a bimodal distribution? And can a skewed distribution also be symmetric? Why or why not? Think about what I talked about earlier when I was explaining which shapes could also be labeled symmetric and one other name. So they're going to give you different distributions. You are going to look at each one and type out which terms describe each distribution. So you want to make sure you use these 5 terms right here. And remember that you can have more than one term describing a distribution shape. So it could be symmetric and bell-shaped. I could fold that bell in half, both sides would match. You have your second shape here. You're going to label it by typing in the box which distribution shapes represent it. You can have more than one. Same for distribution shape 3. Type your answer into the Kidam website. And shape 4. Remember to include all the terms that describe each distribution. Again, the terms that we are looking at in this lesson, they are on the back wall, but we are looking at bell-shaped distribution, bimodal distribution, skewed distribution, symmetric distribution, and uniform distribution. This is an example of bell-shaped distribution. It is a distribution whose dot plot or histogram takes the form of a bell with most of the data clustered near the center and fewer points farther from the center. So if you look, it goes up and then it comes back down and it gives that bell distribution. Bimodal distribution is a distribution with 2 very common data values seen in a dot plot or histogram as distinct peaks. Remember, bi means 2, mode means the peak, the number that has the most results. So in this dot plot shown, the 2 common data values are 2 and 7. So this is one mode, this is the second mode, and therefore it is bimodal. A skewed distribution is one in which one side of the distribution has more values farther from the bulk of the data than the other side, so that the mean is not equal to the median. In the dot plot shown, the data values on the left, such as 1, 2, and 3, those down here, are further from the bulk of the data than the values on the right. If you notice, most of my values are right around 8. So we would say this is skewed, and we would say this is skewed left, because we always label the tail. The tail is down here on the left, so this is skewed left. Symmetric distribution is a distribution with a vertical line of symmetry in the center of the graphical representation so that the mean is equal to the median. In the dot plot shown, the distribution is symmetric around the data value 5. So 5 is going to be kind of my axis here. So if I took this side and folded it over onto this side, they would look the same. That makes it symmetric. And finally, uniform distribution. A distribution which has the data values evenly distributed throughout the range of data. So if we look, this distribution is flat all the way across. That is uniform. There's just as many answers in the beginning as there is in the middle as there is on the end. So, I hope that you are comfortable. If we go back and look at our learning targets, at this point, can you describe the shape of a distribution using the 5 terms we talked about? Symmetric, skewed, uniform, bimodal, and bell-shaped. If you are comfortable describing distribution shapes with those 5 terms, then you are successful at this point. If you are not comfortable, please get my attention, ask me questions, and we will try to make it more clear so that you understand being able to use these 5 terms. Our other learning target was to be able to use a graphical representation of data to suggest a question or a situation that would produce that visual representation. So we got with partners to match up dot plots to histograms and talk about what the shapes were. The next part was to take those matches and try to understand what question might have resulted in that data representation. If you are comfortable understanding how to do that, then you can check that learning target off as successful. If you still have questions, please get my attention so that I can help clarify this for you and you can leave this lesson feeling completely prepared moving forward. So at this point, I just want to thank you for taking the time, whether you were here in class working as a group or whether you were absent, but you took the time to come online, watch this video so that you could stay up to speed with the rest of the class. I really appreciate you taking the time to do that. Remember, if you have any questions about this lesson or a previous lesson, please come find me, get my attention. Email me if you don't feel comfortable asking out loud in front of the class. Catch me in my room after school. But make sure that I help you reach these learning targets because I want to make sure you are set up for success when it comes time for the end of unit as well as your midterm, and then keeping this information so that when you go on to take the PSAT and the SAT, you will remember all of this information and those parts of the test will be easy for you. So again, thank you for your time. I look forward to seeing you in the next lesson. Take care.